In this video, we're going to talk about the steps we need to take to calculate the distance from a point to a line. And when we talk about the distance, we're talking about the shortest distance from this point to this line. So we're going to work backwards and see what we need to figure out, and then that'll set up our plan. So in order to calculate the distance, we know we're going to be using our distance formula. So our distance formula, remember, is the square root of x2 minus x1 squared, so the difference in the x values, plus the difference in our y values, y2 minus y1 squared. But in order to use this formula, we need 2 points. We need x1, y1, and we need x2, y2. And if I want to calculate the distance from this point to this line, I don't have 2 points. I have the point that I was given, but what we're going to need to find out is also this point right there. And that point right there, I don't know what the values are, x2 and y2, and those are big question marks. So that's what we're going to try and find, are those points. So we need the distance formula, so we need to find those 2 points. So that's the next thing that we need to do, or the thing we need to do before we can use the distance formula, is we need to know what that second point is. And in order to get that second point, what we need to recognize is that this red line is going to intersect our given line at a perpendicular angle. That gives us the shortest distance. So in order to find this second point, we need to find the point of intersection between the red line and the blue line. If I can find that point of intersection, then I've got the second point, and then I can use the distance formula. Well, how am I going to find that point of intersection? Well, what I need to calculate first is I do have one equation for my point of intersection, but I need the second equation. So before I can find the point of intersection, what I need to do is to calculate the equation of the red line. Once I know the equation of the red line, then I can calculate the point of intersection using substitution or elimination. Okay, so how am I going to find the equation of the red line? Well, the only thing we know about the red line is we know that it's going to intersect the blue line at 90 degrees. So that means if I find the slope of the blue line, it's the opposite reciprocal slope that I'm going to use to plug in to find the equation of the red line. So let's turn this around and start going the other way. Let's change all the arrow directions, and this is going to give us our plan. So the first thing that we're going to do is we're going to find what the opposite reciprocal slope is of the given equation. Then we're going to be able to find the equation of the second line. Then we're going to be able to use the point of intersection, find the point of intersection using substitution or elimination. That's going to give us our second point, and once I have our second point, then we can use our distance formula. All right, so let's go ahead and do this question and see where we end up. So let me just change pen colors here. There we go. All right, so we said that the first thing that we were going to do was to calculate the opposite reciprocal slope. So the slope of equation 1 is equal to 1/2. So that means the opposite reciprocal slope, which is the perpendicular slope to that, is going to equal the opposite of it, which is 2/1, and the negative of that, negative 2/1. But we don't usually write things as something over 1, so we're going to simplify that, and we're going to write it as -2. Okay. We found the opposite reciprocal slope. We have done step 1. Step 2 says now find the equation of the red line. So to find the equation of the red line, I'm going to plug that into y is equal to mx plus b. And I know now my slope, which was -2, that's going to plug in for this slope here. But what we're calculating right now is the equation of this red line. So let's take a look at the red line. in order to find out what the y-intercept is, I need to know a point on the red line. And I do know a point. This is the given point right up here, 3, 2, that we're going to plug in for x and y. Okay, so I'm going to plug in the point 3, 2 into y equals mx plus b, actually y equals negative 2x plus b, and we're going to see what happens. So the 2 goes where the y is, the 3 goes where the x is, and we end up with 2 is equal to negative 6 plus b, and solve for b, and we're going to add 6 to both sides, so b is 2 plus 6, so of course b turns out to be 8. So therefore, the equation of that red line was y is equal to negative 2x plus 8. So now I have my two equations, and I'm just going to write them over here. I have equation 1 that was given, which was y is equal to 1/2 x minus 4. And I have equation 2 that is y is equal to negative 2x plus 8. All right, so now what I want to do is I want to find the point of intersection between these two equations. Let's go back up and see what we figured out so far. We've got the opposite vertical slope, we've got the equation of the red line, now we're trying to find out what the point of intersection is. All right, and I can do that using substitution or elimination. Because this is telling me that y is equal to 1/2 x minus 4, and this one is y is equal to negative 2x plus 8, I know that this is a different way to write y. Y is 1/2 x minus 4. So what I'm going to do is I'm going to sub y equals 1/2 x minus 4 into the y value of equation 2. In other words, I'm going to sub equation 1 into equation 2. So I'm going to use substitution in this case. So what used to be a y, I'm going to rewrite as 1/2 x minus 4, because that's another way to write y. That's what it says here, y is 1/2 x minus 4. So y is, 1/2 x minus 4, and then we're back here. There's the equal sign, and there's negative 2x plus 8. 8. Good. And let's solve. I don't like this fraction here, so I'm going to multiply everything by 2 to get rid of that fraction. So 2 times 1/2 x is going to cancel out that 2. It's going to look like this. So 2 times 1/2 x, what's going to happen is those 2's are going to cancel. And then minus 2 times 4 equals 2 times negative 2x plus 2 times 8. And when we simplify all that, we're going to get just x here, because those 2 canceled, minus 8 is equal to negative 4x plus 16. We're going to continue to simplify here. We're going to gather our x's together. So I'm going to have x plus 4x, and on the other side I'm going to have 16 plus 8. And x plus 4x is 5x, and 16 plus 8 is 24. So x turns out to be 24/5. Okay, it's not pretty, but it's an answer. So now we know what my x value is. But remember, when we go up to the top here, we need to find out the point of intersection. In other words, we're trying to find out the x value and the y value. We just found out that the x was 25/4. So now what we need to find out is what's the corresponding y value. Okay? So in order to do that, all we have to do is sub what we found out for x back into one of the original equations. So x is equal to 24/5. And I'm going to sub that back into, let's use 2 because it's a prettier equation. There's no fractions there. I'm going to sub that into 2. And that's now going to be y is equal to negative 2. The x I can write as 24/5 plus 8. And we do the math. Don't be scared of the fractions. So this is just going to be negative 48/5. And I'm going to need a common denominator, so 8 is going to become 40/5. And that's going to end up being negative 48 plus 40 is negative 8/5. So therefore, my point of intersection between the red line and the blue line is 24/5 and negative 8/5. Okay, so let's take a look up here again and see where that is. Okay, right here, so we're going to have the point of intersection here now. We know is 24/5 and -8/5, and that seems to fit our picture. Okay, it's a little bit into the negatives. Great, okay, so now we found the point of intersection. Our next step is to find, use substitution elimination to find the second point. So we did find our second point. So now I can use this new point that I just found and the old point that was given to us and use the distance formula. So that's the last thing that I'm going to do. All right, so now step 5 is to use the distance formula. So the distance formula, of course, is the difference in the x values and the difference in the y values. And there we go. Our 2 points that we're considering are the points 24/5 and -8/5 that we just calculated. And the other point came from the original question, how far is 3,2 from the line? That's the other point we're going to use. It's the point 3,2. Now I just sub it into the formula and do the math. So it's going to be x2, doesn't matter which one you choose for x2, let's call it 3 minus 24/5. And I'm going to square that, and now my y2 minus -8/5, so be careful with that because you're going to have that double negative there, is equal to, this is going to be 15/5 minus 24/5, and whatever that answer is, we're going to square it, over, and we're going to call this 10/5 plus 8/5, and we're going to square that. And that's going to give us the square root of 15 minus 24 is going to be -9/5. And we're going to square that. And 10 plus 8 is 18/5. And we're going to square that, giving us 81/25 plus 18 squared, we'll have to figure that out, 25. And when we do all the math, punch it into your calculator, oops, the answer is going to be 4.02 units, approximately.